I would like to discuss some problems with you on chapter 4 before the exam. So it might be helpful for you while you are studying this chapter. So let's start with some formulas and rules of this chapter at the beginning. Let's see. The work equals force times distance, where the force and distance must be parallel to each other. If the force is not parallel to the distance, we must find the angle in between. And in this case, we have to multiply force times distance times cosine theta. But usually we multiply force times distance in most of the cases because we search for the parallel force and distance. Also, the work done on a mass to lift it up a certain height h equals m times g times h. M is the mass, g is gravity, and h is the height. The unit is the Newton meter, which is equivalent to the joule. Energy, and we will study the mechanical energy, has two types, the kinetic energy and the potential energy. The kinetic energy plus the potential energy gives you the total mechanical energy. The kinetic energy is half times m times v square, where v is the speed, not the velocity. And the potential energy, we focus on the gravitational potential energy, which is m times g times h. So half mv squared plus mgh is the total mechanical energy of an object. The unit of the energy also is joule. The power. Power is the time rate of change of energy or the time rate of doing a certain work. So it equals the work over time or also the energy over time. Or the unit of power is joule over second, which we call it watt. The efficiency of a machine equals the output work over the input work. Time is 100 if you need it as percentage. The efficiency can never exceed 100%. Maximum efficiency of any machine is 100%. There is also the mechanical advantage. The mechanical advantage of a machine is the output force coming from the machine over the input force applied on the machine. So the output force over the input force. The mechanical energy can be more than 1 or less than 1 or equals to 1. So it can be greater or less or equals to 1. While the efficiency is always less than or equal to 100%. In the first problem here, if the kinetic energy of an object increases from 30 joule to 120 joule, by what factor does its speed increases? So here he gives us the change in kinetic energy, and he's asking about the change in the speed. You know that the kinetic energy is half mv square. So if you have the change of the kinetic energy, you need to take the square root to get the change in the speed, because the speed in the equation is squared. Okay? So here from 30 joule to 120 joule, that's a change of 4 times. 4 times a change of kinetic energy. So the change of the speed will be the root of this number, which is the root of 4, which is 2. So that's 2 times. But let's try to solve it using mathematics. The first kinetic energy equals 30 joule. The second kinetic energy is 140 joule, 120 joule. Kinetic energy 2 over kinetic energy 1 equals 120 over 30, so that's 4 times. And let's substitute. The second kinetic energy is half times m times v final square. The first one is half times m times v initial square. That's equal to 4. So we can divide both numerator and denominator over half and over m. So we can remove the half with half and the mass with mass. So v2 or v final square equal over v1 or v initial square equals to 4. Then take the root of this equation it will be V2 over V1 equals 2. So V2 is 2 times V1. So the answer is the first one by 2 times. In this problem, a 120 kilogram lone tractor, as shown in the figure below, goes up 3-meter high incline. So the height of this incline plane is 3 meter. That is 12-meter long, and the length of the lone, or the length of this incline, is 12 meter. It did it in 2.5 seconds at a constant speed. What is the efficiency of the incline if the force developed by the tractor is 500 Newton? So he's asking about the efficiency. The efficiency equals the output work over the input work. The force that's done by the tractor is 500 Newton. So the object moved for 12 meter using the 500 Newton. This is like the force of the engine, or the force equivalent to the force of the engine of the tractor. So here we need to differentiate between two kinds of works. The work done by the tractor, by the engine of the tractor, which is its force times its distance. And the force here is 500 Newton, and I'm looking for the parallel distance here. The parallel distance is the 12 meter. So it will be 500 times the 12 meter. This is the input work, or the work done by the tractor. And the work done on the tractor to lift it up a certain height is the mass of the tractor times G times the height of this lone, or the height of this incline. So the work done equals mass times G times H. The mass is 120 kilogram. G is 9.8, and H is the height of the lone, which is 3 meter. So now I know the input work and the output work. The input work is the first one, and the output work, which is the result of the motion, which is the second one. So the efficiency, as we remember, is what? The output work over the input work. The efficiency equals the output work over the input work. 120 times 9.8 times 3 divided by 500 times 12 times 100 to get it as a percentage. So the result is 58.8%. This problem, a certain lever has a mechanical advantage of 5. So the mechanical advantage, as you remember, it's the output force over the input force. So we need to look for the output force of this machine and the input force of this machine. That's the mechanical advantage. The mechanical advantage here is 5 times. So he's asking how heavy of a load could the lever lift with a force of 30 Newton. So if you give the machine or this lever 30 Newton force, what's the output force, or here what's the mass or the weight? He's asking for the weight that it can handle. So the input force here is the 30 Newton. The output force is the required. The mechanical advantage is 5 times. This is a lever, for example. If you apply a force and you need to lift a certain weight upward, the force is the input force, and the weight is the output force. And the mechanical advantage, how many times you increase your force, that's the mechanical advantage. It's 5 times. The output force here is the weight. So the output force equals 5 times the mechanical advantage. So the mechanical advantage is 5 times the input force. So that's 5 times 30 is 150 Newton. The crane shown in the figure below lifts its 500 Newton load, the load at A, at the point in the drawing here, to lift a 500 Newton load. So this is the weight of the load. The weight is mg, not m. This is mg. It's 500 Newton. To the top of the building, to point B, at the top of the building, as you see, the height of the building in the drawing is 40 meters. From point A to point B. Distance is shown, how much work is done by the crane. We need to find the work done by the crane. But here he needs to say that the efficiency of the crane or the process is 100%. Okay? So the work done on the mass to lift it up a certain height is m times g times h. So in this case, the work done is the mass of the object times g. Mass times g is the weight, which is 500. Times h. What is the height of this building? The height of the building is 40 meters. So I will multiply 500 times 40. It gives you 20,000 joule. So the work done on the mass is 20,000 joule. And assuming 100% efficiency, so the work done by the crane will be also 20,000 joule. Some people might ask, like, but the motion is from A to B directly. Why did you take only the mgh and you neglect the other part? Here the force is upward. The force of the crane is upward. So when the crane pulls the object upward, it does work, and its work will be mgh. But in the second part, when it moves horizontally, there is no work here, because the force is upward while the motion is horizontal. And we remember that, and we discussed it in the class. If the force and distance are perpendicular to each other, so the work at this time is 0. So there is no work at this part. The work only is the vertical work or the vertical motion part, and it's m times g times h. So the work is the mg, which is 500 Newton, times the height, 40 meter. The result is 20,000 joule, assuming 100% efficiency. In this problem, the figure below shows a ball swinging freely in a plane, ignoring friction. What is the maximum speed of the ball as it swings back and forth? At point A and at point B. At point A, as you know, that's the zero speed, so that's zero kinetic energy. And the mechanical energy at A is only potential, mgh. While at B, this is the maximum speed of the pendulum. The maximum speed of the pendulum or a swing is at the lowest point. And at B, there is no potential energy. The potential energy is 0. So the mechanical energy at A is potential energy, which is mgh. The mechanical energy at B is only kinetic. So the mechanical energy at B is kinetic energy only, which is half times m times v square. So if we assume no loss, there is no friction and there is no air resistance, I can equate the mechanical energy at A to the mechanical energy at B. So mg times h at A equals half mv square at B. Very easy to solve this equation. Divide over the mass in both sides, at both sides. So gh equals half vb square. So the vb is 2 times g times h under a square root. We know g is 9.8. H is given here in the drawing. It's 2.5 meter. So the result is the root of 49, which is 7 meters per second. So the bead of a mass m is released from point A and slides on a frictionless track shown in the figure below. What is the bead's speed at point B? So this is a pretty straightforward problem that is on the conservation of mechanical energy. So as the plane here is a frictionless track, so we can equate the mechanical energy at A to the mechanical energy at B. The mechanical energy at A, it has two parts. the potential energy and the kinetic energy. But here he said it was released at A. So the speed at A is 0, so there is no kinetic energy and it's only potential energy at A. But at point B, we have a height and we have a speed. As we have a height, which is a 2 meters, so we have mgh, a potential energy. And also, we have a kinetic energy, which is half times m times vb square. So we will equate the mechanical energy at A, which is mgha, to the mechanical energy at B, which is the kinetic plus potential. And as we see here, we can remove the masses from all the terms. And then we can take mghb to the other side with negative sign. So it will be g, we can take it as a common factor if you want. And we can write it down g ha minus hb, okay, g times ha minus hb, which is better, equals half times vb square. We know ha is 5 meters and hb is 2 meters. So we can find vb, and do not forget the root 2. We will take the half to the other side. It will be 2 times g times ha minus hb. ha is 5, hb is 2, so 5 minus 2 is 3. 3 times 9.8 times 2 under the root, which is 7.67 meter per second. There is another way we can do it, which is a little bit simple, but it's the same method. We can take a new reference other than the ground. So we will measure the height from point B instead of the ground. So the height of point B now is 0. And the height of point A will be measured from the new reference, which is 3 meters. So now at point A, we have potential energy, which is mgh. And at point B, we have kinetic energy, half mvb square, but we don't have height. So the equation will be very simple now. mgh is half mvb square. So vb can be found that it's the root of 2 times g times h. 2 times g times h. So 2 times 9.8 times 3, which gives you the same number exactly, 7.67. Which of the following is not a mechanical energy? Of course, the chemical energy is not a mechanical energy. Although you can convert the chemical energy into a mechanical energy, like through the car engine. You can burn the fuel in the engine, so it turns the chemical energy into thermal energy, and then by its turn, the thermal energy changes into kinetic energy in the engine. The elastic energy is a mechanical energy. The gravitational energy is a mechanical energy. Kinetic energy is a mechanical energy. So the only one which is not a mechanical energy is chemical energy. If runner's power is 400 watt, as he runs, how much chemical energy in calories does he convert into other forms of energy in a time 10 minutes? The calorie is a unit for the energy. 1 calorie equals 4,000 joule, as he gives you here a hint at the end of this problem. So we need to remember what is the power. Power is the work over time or energy over time. Power is 400 watt. And as you remember, the watt is, yes, joule per second. So your units must be joule and second. So if you get the energy, you will get it in joule, and if you use a time, you need to use it in seconds. So the time here is 10 minutes, not seconds. You need to convert it into seconds, which is 10 times 60, that's 600 seconds. So power is energy over time. So the energy is power times time. So the energy which is required equals the power, 400 joule per second, times the time, 600 seconds. The result will be 240,000 joule. 240,000 joule. The result you get is in joule, and you need to convert it into calories. 1 calorie is 4,000 joules, so you need to divide this number over 4,000. So 240,000 divided by the 4,000, 60 calories. So the first answer is the right one. A worker pushes a crate weighing 93 Newton up the inclined plane. In this problem, the worker pushes with a force 85 Newton horizontally, not parallel to the plane. And how much work does he do? We need to find his work. So we are looking the work that he does. And the work that he does equals what? Equals his force times the distance times cosine theta. So the work that he does equals his force times the distance that the object moves on times cosine theta. So his force here is the 85 Newton. And the distance that the object covered is 5 meters, which is the length of the inclined plane. And cosine theta is the angle in between. So cosine theta here is adjacent over the hypotenuse, which is 4 over 5. 4 over 5. Okay? So 85 times the 5 times cosine theta, which is 4 over 5. The theta is the angle of the incline. So the result is 340 joule. This is the work that he does on the mass. The work that he does to push the mass up the incline. There is another method. We can directly find the parallel distance to his force. If you look, we have here 3 distances. The real distance, which is the 5 meter, and there is its projection on the ground, which is the 4 meter, and there is the vertical distance, which is the 3 meter. So I'm looking for the parallel distance to the force. Yes, this is the horizontal distance, which is the 4 meter. So we can say that his work equals his force times the parallel distance, which is the 4 meter. So we can multiply 85 times 4 gives you 340 joules, so it's the same answer. So you can use both equations. And it gives you the same answer. Here we need to differentiate between the work that he does to lift the object up the incline and the work that is done on the mass. The work that's done on the mass is mgh. So we can consider the incline as a machine. You apply a work which is an input work, the 340 joule, and there is an output work. The output work is the mass times gravity times height, mgh. So if we need to calculate the output work, which is not required in this problem, by the way, it's not required here, but let's assume that he will ask about it in another problem. So what's the work done on the mass? The work done on the mass is W on the mass is mgh. So the mass times gravity is the weight of the object, which is given here 93 Newton. And the height here is 3 meters. So it will be 279 joule. This is the output work. Okay. What if he asks for the efficiency of this incline? How to get the efficiency? The efficiency is the output work over the input work. The output work here is the 279. And the input work is 340. The efficiency is the 279 over 340 times 100 to get it in percentage. The answer is 82%. So in case if he asks you about the efficiency, you can get it by the output over the input. So in this problem, a ball of mass m rolls along a flat surface with a speed of vi. This is the initial speed of the object, vi. It strikes a padded wall and bounces back in the opposite direction as in the figure below. So the new speed after it bounces back is v final. The energy, v initial and v final. the energy of the ball after striking the wall is half its initial energy. So the object lost half of its initial energy. By the energy here we mean the kinetic energy, because there is no potential energy. So we mean the kinetic energy. It lost half of its kinetic energy. So we need to find, ignoring friction of course, which of the following expressions give the ball's new speed as a function of its initial speed. So what's the ball's new speed as a function of its initial speed? When the object loses half of the kinetic energy. So the kinetic energy final equals half the initial kinetic energy. So what about the speed? We know that the kinetic energy is half times m times v square. So if you lost half, so the speed will be the root of half, the root of 1/2. So v final equals the root of v initial. And the root of 1/2 is the same like what? Like when you write it root 2/2. Root 2/2. So the first answer is the right answer. But let's try to do it mathematically. Let's try to do this solution mathematically. The final kinetic energy equals 1/2 the initial kinetic energy. And the final kinetic energy is half mv square, the final speed square, equals 1/2 times the initial kinetic energy, which is 1/2 times m times v initial square. Now we need to solve this equation. We can remove the half with half, and we can remove the mass with mass. So the leftover is, yes, v final square equals 1/2 times v initial square. So we need to take the square root of the equation, of the whole equation. So v final equals the root of 1/2, which is 1 over the root 2 or whatever you want to write it, times v initial. So this is the right answer, which was found before. So the right solution is number A. So in this problem, the slider shown in the figure, it starts from the top of the frictionless hill at height 40 meters and slides down into the valley if the initial speed is 15 meters per second. What will be the speed at the top of the next hill, which has a height of 50 meters? So we have the mechanical energy at the beginning equals the mechanical energy at the end, and we need the speed at the end. So the mechanical energy is kinetic energy plus potential energy. So the point here is we will equate the mechanical energy at point A to the mechanical energy at point B. Mechanical energy at A is mgha plus its kinetic, which is half times m times v square. Of course, that the speed here is not zero, because he said the speed is 15 meters per second. And this is equal to the mechanical energy at the end, which is mghb plus half times m times vb square. So we can solve the equation by, we can remove the masses from all the terms, like you divide over the mass in all the terms. Then you can solve it mathematically using any method. You can take GHP to the right hand side and subtract them from each other. Okay, we just need to find VB. So G here is 9.8 times HA, which is 40 meter, plus half times VA. VA here is 15 meter, it will be squared, equals 9.8 times HB, which is 50 meter, plus half times VB square. Take everything to the other side and find VB. It will be the root of 9.8 times 40 plus half times 15 square minus 9.8 times 50. And all of this will be times 2. The half will go to the other side, will be times 2. And we need to take the root for everything. .38 meter per second. 5.38 meter per second. So the first choice, 5.39 meter per second, is the right answer. Which of the following statements is true? Work does not have direction. This is true. Work and energy, they have no direction. Okay? But there is positive work and negative work. Positive work means you give energy to the system or to the object, and negative work means you take energy from the system. So you increase or decrease the energy, but it has no direction. Okay? So this is the right one. Number B, the rate at which energy is converted from one form to another is called the acceleration. Of course not. The rate at which energy is changed with respect to time, that's called the power. Number C, chemical potential energy is a mechanical energy. Of course not. But you can convert chemical energy into mechanical energy through, like, the car engine. You can burn it to a thermal energy, and the thermal energy also is changed into mechanical energy or kinetic energy. The last one, bicycle is a simple machine. No, bicycle is a compound machine. Okay? So a 0.25 horsepower motor is used to lift a load at the rate of 5 centimeters per second. So the horsepower is a unit of power. 1 horsepower is 746 watt, as it's given here in the hint. So here he gives us the power, and he gives us the speed of the object. He's pulling the object upward, and this is the speed, 5 centimeters per second. How great a load can it lift at this constant speed? And he's asking here about the mass of the object. As we remember, the power equals the work done, the work over time. So the work is force times distance. Force times distance divided by time. Here the distance is the height. So we can say that this work is mgh, because it's the work done to lift an object against gravity. So it's mgh. mg is the weight of the object, and h is the height. Height over time, or the distance over time, gives you the speed. So we can rewrite the equation as mg times v, and v here is the speed of the object. So the power can be given as a force times speed, or in this case it's the weight times the speed. We know the power, it's 0.25 times 746 to convert it into watt, and you know the watt is joule per second, equals the mass, we don't know it, gravity is 9.8, the speed is 5 centimeters per second. We need to convert it into meter per second. So 5 centimeters per second, it will be 5 over 100. So it will be 0.05, yes, 0.05 meter per second. The result is 380.6 kilogram, which is very close to the first choice, number A. So in this problem, a block slides down a smooth ramp starting from rest. So the object is on the top of the ramp, starts from rest at a height, let's say the height is h, and the speed is 0, starts from rest. When it reaches to the bottom, it's moving at a speed v. So the object, when it reaches or slides down to the bottom, so the height will be 0, but it will have a speed v. It then continues to slide up a second smooth ramp. So it will move up on a second smooth ramp. Okay. At what height is its speed equal to v over 2? So at a certain position, of course, its speed slows down. So at a certain position where the speed is v over 2, we need to find this height. So at this position, the speed is v over 2, and we are looking for the height at this point. Here we have 3 positions. Position number A, we have only potential, mgh. And position number 2, in the middle, we have only kinetic, half m times v squared. Position number 3, the green one, we have potential and kinetic. let's assume that the positions are A, B, and C, so the third height will be hc. So we have the potential mg hc plus the kinetic half times m times the speed square, and the speed is v over 2. Of course, when you square it, it will be v square over 4. We are searching for hc. We are searching for hc. So let's equate the second part of the equation to the third part. Second part to the third part. So half m v square equals mg times hc plus half times m times v square over 4. It will be here v square over 4. So we are looking for hc. We need to solve this equation to find hc. We can remove the masses, like divide all the terms over m. Take this one to the other side with negative sign. So g times hc equals half v square minus half of v square over 4. We can take half times v square as a common factor. The leftover will be 1 minus 1 over 4. So 1 minus a quarter is 3 quarters. 3 quarters. 3 over 4. So it will be 3 over 4 times half v square. So that's g times hc. So we're looking for hc. So you need to divide over g. Divide everything over g. But the choice is here, it does not have v, it has h. So we need to get rid of the v and substitute it with a term that has h. Yes, let's look at the first and second equation. Equate both of them, remove the masses, so you'll find that v is 2 times g times h. The half is taken to the other side. Okay, and then substitute it again in this equation. So hc is 3 over 4 times half. Then I will remove the v square and write it down 2 times g times h. 2 times g times h. Then simplify it, remove g with g, the 2 with the half. So the leftover is 3 over 4 times h. 3 over 4 times h, which is the first choice. In this problem, 2 marbles, one twice as heavy as the other. They are dropped to the ground from the top of a building. Assume no air resistance. So we drop 2 masses, A and B. The first one is twice the mass. So if we consider the first one is m, or the second one is m, the first one will be 2 times m. This is the masses. And then we will drop them at the same time from the same height. We need to compare between the kinetic energies at the end. If we think of energies, what is the energy of each one at the beginning? The energy of each one is only potential, and both they have the same height. So the first one has double or twice the potential energy as the other. So the first one has double or twice the potential energy. When you leave it to reach to the ground, all the potential is converted into kinetic. So at the end, the first energy is also twice the second energy, but now the energies are kinetic energies. So the first kinetic energy is twice the second kinetic energy. So I will choose twice the kinetic energy of the light marble, which is choice number A. You might think that the heavier one has more speed, but that's not right. Okay, because they will, when you drop them, they are under the effect of gravity. And if you remember the equation of the gravity, so the equation of the gravity is v square equals v initial square plus 2gh. That means the initial speed is 0. So v square equals 2gh. So v is root of 2 times g times h. So the final speed depends only on the height, not on the mass. They were dropped from the same height, so they will have the same final speed. So the change in kinetic energy here is because there is a difference in mass, not a difference in speed. Okay? Also the time, they will reach to the bottom of the building at the same time. So they will have the same time and the same speed. But the first one will have twice kinetic energy as the other because it has twice the mass. Okay? I hope this video is helpful for you, and I hope you study well and prepare yourself for the exam, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.